Hello students, welcome to another video for class 8 physics. Today we are going to discuss about the chapter light. So let us begin. So what is light? Light is a form of energy. You have read about light in class 7 as well. And you know there are two important phenomena which happen, that is reflection of light, which you have already covered in class 7. And in class 8 you are going to deal with the refraction of light. Now what is refraction of light? It is a bending of the light when it travels from one medium to another. It's known as refraction of light. So I have drawn a diagram. Let us see what are the points given here. In this diagram I have tried to show you two medium, air and glass. The air is a rarer medium because the particles of air are far away, and glass is a denser medium as compared to air because in glass the particles are closer. So when I say that one ray is passing through the air and striking a point O, suppose here, and it is actually believed to go straight, but it does not. It bends towards the line which I have drawn here, which is known as the normal. Now this bending is closer to the normal, as you can see, and it happens because the glass is a denser medium, and when air passes from the rarer to the denser medium, it tends to move closer to the normal. So I have written down some points like incident ray, reflected ray. Let us understand what do these points mean. So when I talk about the incident ray, as I showed you, this is the incident ray. So from the name itself you can understand that the ray which is falling on the surface is the incident ray. Similarly, refracted ray, this ray which I have drawn here is the refracted ray, this one, not the dotted one, the straight line which has moved closer to the normal. So the ray which is getting deviated from its original path, actually it was supposed to come here, but it has deviated from its original path and moved towards inside or towards the normal, is known as a refracted ray. And then we have a point of incidence O, and the point O on the boundary from where the incident ray is entering into the second medium is known as a point of incidence. And there is a normal here. This line is actually an imaginary line which is perpendicular, and it is also passing through the point of incidence, as you can see, and this is at 90 degrees to the surface. Also you can see two important angles that I have marked, that is angle I, that is the angle of incidence, which is the angle made between the incident ray and the normal, and then angle R, that is the angle of refraction here, which is the angle made between the refracted ray and the normal. Now let us move to understand about the laws of reflection. So now speaking about the laws, there are two main laws: refraction, like we had the two laws of reflection. So the first law states that the incident ray, the normal to the point of incidence, and the refracted ray all are in the same plane, as I had shown you in the diagram before, and I will show it to you again, that this, the normal and the point of incident and the refracted ray all are lying in the same plane, right? And the second law states that based on the pair of media that we are using, like I showed you air and glass, right, through which the light undergoes refraction, the ratio of the angle, the ratio of the sine of the angle of incidence to the sine of angle of refraction is always a constant. That constant is called refractive index, okay, of the second medium with respect to the first. And this law is also known as a Snell's law because it was given by Snell, the scientist, the physicist. And if I want to define the refractive index, I can say it is refractive index of a medium is the ratio of the speed of light in vacuum to the speed of light in that particular medium. So generally when I say the refractive index, I tell about the second medium as compared to the first medium. So as I told you, refractive index is speed of light in vacuum or air, because it's more or less same, by speed of light in a medium. And also you need to remember, children, that the speed of light in a medium of higher refractive index is always less. And we can say that more the speed of light is slowed down as it enters another medium, right? Because if the medium is a denser medium, the speed will definitely reduce, because there are more particles to resist or to stop or lower the speed. Therefore, the greater will be the refractive index of that medium, and the larger will be the deviation of the light from its original path. So when it is coming to a denser medium, because of the decrease in speed, it's coming closer to the normal. But when it will go to a rarer medium, it will be moving away from the normal. It will increase in speed. Okay, children? Now there are some unique properties of refraction that you need to understand. As you can see, I have done 3 diagrams showing you the medium air and glass. And in the first case, I have written that the incident angle of incidence is greater than angle of refraction. As you can see, it is obviously more. The I value is more here than the R value. So when will it happen? When a ray of light entering a denser medium, okay, like from, for example, here it is air to glass, it always bends towards the normal. So it's definite that the angle of refraction will be less than the angle of incidence in this particular case. Then we talk about another case where suppose the incident ray is coming from the glass and it's moving out. So you can see the angle of refraction is increased here. So angle of incidence is less than angle of refraction. So this is happening when a ray of light is traveling from a denser to a rarer medium, which is always, it will bend away from the normal. And in this case, as I can tell you, angle of incidence will be less than the angle of refraction. And moving to the last case, where you can see that the ray of light is traveling along the normal. So the incident ray is coming, it's exactly same like the normal, which is perpendicular actually, and it does not suffer any refraction. It's just going straight, so it's bouncing back in the same. You can see the arrow, one is going in and one is coming out. So in this case, what is happening? Both the angle of incidence and angle of refraction will be 0, because they are not forming any angle with the normal. They have become equal to the normal. So if there is no angle being formed, so the angle of incidence and the angle of is going to be 0. Principles or the unique properties that you need to remember. Now based on this, I am going to show you a few real life examples that refraction happens in nature and how it works. So please see this. So students, you can see that I have dipped a pencil in water, and can you see how different it's looking from here? And if you just see from the top as well, you will feel that the pencil has become bent. Now why does this bending occur, children? You know that when light is traveling from the inside of the water, that is, it is a denser medium and it is coming out. So what is happening? Because it is coming to the rarer medium, that is air, it is suffering refraction at the boundary of the two media, right? And when it is suffering the refraction, it is moving away from the normal as it is coming out. And if we think that the light is going from inside to outside, you can say that it's moving towards the normal, because outside to inside when I talk, and if the rays are passing from the outside, the air medium to the glass water medium, then obviously the speed of the light will change. Also the pencil is appearing bent. Also, if we replace this experiment with a coin, let us see what happens. Now the second experiment that I will show about the effects of refraction, I have a coin with me here, and I put the coin inside. You can all see the coin, and you just see the angle here. As you can see, the coin is at the bottom, and now you will see what is going to happen when I put water inside this. The coin is still lying at the bottom, but if you see it here, it looks raised. It feels as if it has come on the top. So why does the coin look raised, children? This is again because of the refraction of light. So these are some day-to-day normal examples of your refraction. You can see, like when you stand inside a tank maybe, or in the swimming pool, your legs seem bent and raised up. It looks shorter. It is again because of the refraction of light. So if children, you have liked the video, don't forget to like, share and subscribe. You can definitely comment more examples of refraction in the comment box. Thank you for watching.